I'm thinking a lot more recently about localized cooling and fire prevention. Things like marine cloud brightening. There's a lot of basic science that still needs to be done. Like my understanding is that it's unclear whether marine cloud brightening net produces warming or cooling. And scientists think it's highly dependent on maintaining really tiny molecule size with your aerosolized saltwater, which is really hard and maybe impossible. So like more basic science on that, particularly things like marine cloud brightening and other localized things, because people are going to start deploying those. They're tired of seeing their cities burn or cook.
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I am thrilled to be speaking today with Luke Iseman, the founder of Make Sunsets, a company on a mission to cool the Earth quickly with stratospheric aerosol injection, which is a fancy way to say that they're putting clouds in the sky to reflect sunlight. We've had a lot of guests on the show focused on longer-term solutions to climate change that reduce or remove emissions, but many of those could take decades to have a meaningful impact. And the reality is we're already seeing the effects of climate change now. Global average temperatures just officially exceeded 1.5 degrees of warming. We have the fires raging in LA as we speak. So a lot of people would argue that we just don't really have a lot of time to wait. So I'm really interested to learn more about what Luke is up to and what kind of impact it could have in the short term, and also what challenges he'll face in scaling the solution. To introduce Luke quickly, he is a hardware startup veteran. I actually first met Luke when he was the director of hardware at Combinator, where he helped hundreds of startups with hardware products through their journey, and also helped put YC on the map for hardware companies. He has also founded a number of startups himself, mostly hardware-based in spaces like precision agriculture, biochar, and affordable housing, all before founding Make Sunsets in 2022. He seems actually so perfect for our show that I'm a little embarrassed it's taken me over 2 years to have him on as a guest. Luke, thanks for being here. It's great to have you.
Yeah, thanks for having me. I'm excited to be here.
I was curious, just to start us off, because you've had such a unique perspective on this. In the last 10 years, or in your time as a hardware founder and helping all these startups, how has the world changed for hardware founders?
I don't think it's really changed that much. Like almost everything you could do 10 years ago, you can do now. I think that it's a little more widely recognized how quickly you can do things, or a lot more, frankly, how quickly you can do things as a hardware startup. There's still a lot of, I call them like dumb engineer excuses, like trying to make things work with 9 nines reliability before you show it to anyone. And that's good. It's like if showing it to someone means they're like flying on your experimental aircraft, then yeah, 9 nines or a little less in a parachute makes some sense. But when we're talking about things like emergency action to keep our state from regularly catching on fire, or millions of people from dying in preventable heat waves, then, one might argue we need to move a little quicker. There's no tool that I or any of my other founder friends use that didn't, other than, generative AI, which actually can be really helpful for some brainstorming. Other than that, everything we use has existed 10 years ago. It's maybe a little faster, a little cheaper. Like 3D printers suddenly became really, like at-home 3D printers became awesome in the last 3 years and cost less than $1,000. That was like, they were okay, but now they're just amazing. Like detail changes like that, but nothing systemic. It's just more faster and cheaper, basically.
And what is it that keeps you focused on hardware? And maybe, how did you get into it in the first place, and why such a clear focus on hardware throughout your career?
I was really, really tired of sitting in a software company cubicle and didn't so much have a plan as know that I didn't want to keep doing that regardless of if it continued to pay well. There's just so much opportunity with hardware and so few people working on so many really important challenges. with Make Sunsets, it was just like, it was unbelievable to me that no one had done this thing that scientists universally agree creates a substantially leveraged cooling effect for the planet. And like, other than volcanoes, nobody had bothered to intentionally do it ever at all. And that's just, this is particularly extreme, but there's so many things as you start to look at hardware that founders used to being like, startup solution number 307 in a category founders, they'll be like, wow, there's almost no technology in this. Like, I talked to a buddy yesterday who made the smartest chicken coop in the world by far. And that's, I mean, one, his product's cool, but two, there's no smart chicken coops at all. This is something that like tens of millions of Americans do. I've had chickens for years. It's fun, but could be much more enjoyable if you got rid of most of the simple manual labor. And there's so many things like this. He's building a very real business with smart chicken coops for home chicken people. I mean, there's so much, especially as people realize that we need to change how centralized a lot of our systems are and how reliant on, somebody else to put out the fire or deal with the waste or grow the food we can be. There's really excited about.
Relative to software only or other kinds of solutions, it's almost, I think you're saying there are just more unsolved problems in the hardware space. There's more opportunity for novel solutions.
Yeah, I think that's a good way to put it. I joke with software founders, I'm like, la ti da, you have zero marginal costs. But while that's nice for them, people don't often, at least consumers, don't expect to pay for software, or certainly don't expect to pay much. So, grass is always greener, but fundamentally hardware is can solve real world problems, and and companies are ready to pay for it.
That's kind of very related to my thinking about almost starting the show, Hardware to Save a Planet. That climate change is a physical problem. We need physical technology to solve it, at least in part. I'm curious what your journey, climate and sustainability, has been, because it looks like you've touched on this in a number of ways with your different startups. You've done things in precision ag and affordable housing, which is related. Like, has sustainability been sort of a goal for yours or has it been more of a place where it's obvious that there's hardware solutions, or a bit of both?
More the former. Until Make Sunsets, it's been mainly about building things that I wanted for myself. Like, I wanted a smart house built out of a shipping container, and I'd built a somewhat working one, and some friends were living in other versions of it. And I can paint a picture for myself of why this thing is good for the world. Same with my soil sensing startup, where, I was tired of killing anything I tried to grow. So I tried to make a somewhat smarter gardening sensor, and I have to be able to tell myself a convincing story about why the world needs this, and I have to personally want it. Those are kind of my pretty hard standards for what I work on.
Let's talk more about Make Sunsets and why, of all the things you could do, this was the thing that kind of caught your attention and you're dedicated to now.
Yeah. So we launch balloons full of sulfur dioxide and a lift gas to the stratosphere. They go at least 20 kilometers up, or they don't count as fulfilled orders for our customers. They go up, they burst, and they release sulfur dioxide, one of the main things that volcanoes release. What this does is it reflects a little bit of sunlight back into space before it can warm the earth as much as it usually would. We don't solve all of the problems of human impacts on nature, but this is a direct, very quick, and extremely cost-effective way to deal with warming. And I didn't think this was going to be a company at first. I mean, it's a startup, and the jury's still out. We're not profitable yet. But as I read Neil Stephenson's Termination Shock, and then later some other science fiction, I just couldn't stop thinking about this. The more research I did, the more confused I became, because there was strong consensus from UN IPCC down to individual scientists that sulfur dioxide emitted in the stratosphere, emitted at any altitude, but particularly effective in the stratosphere, creates a cooling effect. Yet no one had intentionally done it. So I dug into the literature more, got a hold of some of the lead researchers, and couldn't get any answer as to why no one had done this, other than politics and controversy and blah, blah, blah. what really pushed me over the top to do it myself was realizing that it was like $500 worth of materials to try this myself. And I didn't have telemetry to confirm whether my balloons actually made it up or not, but I bought some sulfur, just the yellow powder. It's sold as a gardening amendment. You can buy it on Amazon, lit it on fire in an outside area, so tons of ventilation because it produces sulfur dioxide, which reacts with water vapor to produce sulfuric acid in your lungs. You don't want to breathe much of it. Pumped a little of the resultant gas into a balloon, added some helium into a large weather balloon, added some helium, zip tied it shut, and let it go. And then, felt good about myself, launched another, and kind of went on with my day and gave myself a hard deadline of, I've read enough histories of innovators, and fringe technology, especially if it's something that flies, is kind of a way that people way smarter than me and more wealthy have devoted their entire, some might argue it has taken over many smart, wealthy people's lives. So I set a hard limit of $50,000 in 8 months. And by then I'd either figure out someone to work on this with me, someone to fund it, some customer or something, like some way to do this and have it produce some result other than just feeling good. Or I would just publish whatever I had as like an Instructable or something and move on with my life. And about 5 months into that, I was lucky enough to have been blabbing about this to any friend who would listen, in, my siblings, my family, my girlfriend, startup founders who I'd worked with, basically anyone who would listen. And eventually at some point, someone refers me to a friend who had a venture fund focused on sci-fi technology. I'm like, oh, this will be a fun conversation if nothing else. After a couple conversations, they ended up writing the first check. And some other people added funding. That was Boost Ventures. Yeah, they're just focused on investing in they call it deep tech now. It's a little more buttoned up, but it's stuff from the comic books that Adam Draper and the other founders read as kids, that they want to see in the world. And it's a great investor to have. I then was able to convince my co-founder, Andrew, I made a list of the best salespeople that I knew. I knew I wanted to focus on the hardware, and I wanted to do everything but sales. So I wanted to find the best salesperson I could, and was able to convince the first person on that list I made of the best salespeople I knew to join as my co-founder. And yeah, we've been at it ever since. We kind of were forced into publicly launching. MIT Technology Review contacted us like Christmas Day, 2.5, 3 years ago, 2 years ago, I guess. And they said they were going to write about us. Whether or not we wanted to be quoted was up to us, but like it or not, that we existed and what we were doing was going to be made public. So kind of scrambled to at least have our Shopify store launched and explain what we were doing and why a little faster and more publicly than we'd planned.
Is nobody else doing this?
There's a researcher in the UK who claims to have done a couple launches. I believe him. And then no one else claims to have done launches. Technically, we sometimes we'll have customers and friends join us, and we've had several of them release the balloons. We also will often give away small balloons, like 6-inch latex party balloons, which are biodegradable. Everyone always asks, with some helium and some calcium carbonate or chalk dust in them. It's technically unlikely that many or any of those make it all the way up to the stratosphere, but regardless of where they burst, they're putting some reflective powder into the air. So we've minted well over 200 geoengineers from people releasing our little balloons.
I do want to give a little airtime to why people haven't done this, or like what the sort of controversy. You mentioned politics and controversy. Can you flesh that out a little bit? Like, why do you think people aren't doing this, or what are you going to run into as challenges in those categories?
The argument that gave me pause, like where I stopped what I was doing and thought deeply about it for several weeks, is perverse incentive. That if humanity has a tool to not need to cut back on our use of fossil fuels, we tend to be as lazy as we can get away with. We'll use that tool. And I thought about that for a while. And then I got out of my mental ivory tower and looked at the numbers a little bit and realized that, fossil fuel use, greenhouse gas emissions go up year after year. We're not only not making any material progress, zooming out to atmospheric levels of CO2, we're not only making little to no progress, we're proactively making the problem worse year over year. So the real politic of this is that, we need this. And most academics in the field, a lot of policy people consider it inevitable. They'll then bicker with me about like the politics of it. And, is this making it harder for legit researchers to do it? Blah, blah, blah. At the end of the day, no one else was doing it. So like you can't, and I like on these thorny political, philosophical things, occasionally we need to zoom out and try to quantify things. And, me not doing this when no one else was doing it, like it's not like a negative amount of this can possibly occur. It can't be any worse. It can't be any less occurring than there was before I started. I would suspend false modesty a little and argue that we've been one of many factors, but we've been a very real factor in a crazy acceleration in both awareness of solar geoengineering as well as funding flowing to it. Most of it not to us, but many large environmental groups are now doing, and they'll couch it in different ways. And typically donors will only right now give to studies about the politics or the logistics of someday maybe doing this. But that didn't happen, other than Gates and a couple other people. That didn't happen 5 years ago. It's in the last year, really year and a half, 2 years, that this has really started to accelerate. And some of this is activism for me. I plan to build a very real and very profitable business, but I'm very excited. And I tell researchers who complain about this, use us as an example. Like, be like, hey, we need funding for our responsible adult quantified university efforts because these goofballs are going to just be launching balloons. And this is what happens when, you responsible adult funders don't fund us brilliant researchers. That's fine. Like, I don't really care how this gets done, whether it's us or someone else. That this needs to get done and by this, I mean directly cooling the planet to offset some, but not all of the harms that our greenhouse gas emissions are causing.
Maybe say some more about that, because I think what often comes up in conversations about various solutions to fight climate change is, well, if we're doing this, we're not doing that. So if we're investing money in, geoengineering or aerosol injection, we're not investing in carbon removal or in renewable energy, or there's finite dollars to move around. Like, what do you think is the right way to look at that? Do we need to be doing all of it? Should we be putting more resources towards this and less towards these sort of longer term solutions? What does that look like for you?
I think that given how severe the climate crisis is, like 6 months ago, and if I was, being more politic, I would say what I usually do, which is that it should be an improv approach. Yes, and we need this, and we need that. We need that. We need all of these measures. But to be honest, increasingly, I feel that climate change is so dire, and politically, it's so clear that we're not only going to burn proven reserves, but continue to obtain more reserves and like to continue to find new fossil fuel and other resources and burn them basically as quickly as we can get them out of the ground. So like we should really look at adaptation a lot more and fund it a lot more. We should stop pretending that we're magically going to put in a couple extra solar panels and pull carbon out of the air, because like you can't pull the amount of carbon out of the air that we need to given current technology. I would instead of building more super inefficient giant fans, fundamental research, particularly in fusion and fission and deployment in fusion, as much as we can, fusion and fission, getting that to be a reality to where we have a surplus of energy. So if we need 1 million big inefficient fans to pull out carbon dioxide, then we can afford that from an energy perspective, because now we can't, frankly. I think we need more adaptation, and I think we need more direct climate measures like ours. Longer term, a thing that's far better than us is something that extremely few people are working on and almost no one is funding, which is to put in a planetary sunshade, to put a tunable structure in space at the Lagrange points that it kind of more or less stays in place without much effort, to block some, but not all, of the sun's energy from reaching the planet. And, zooming way, way out, like clearly as we advance as a civilization over the coming millennia, we'll develop all of these things. I think being smart about what we actually develop, not doing, dumb shit like having a trade war over tariffs on electric cars. There's a lot of dumb stuff we obviously shouldn't do. Some incentive stuff that seems like it could be cool and incremental technology that, is probably helpful. But then a lot more like focusing on the fundamentals, like how do we cool the planet to buy us time to cost effectively reduce carbon dioxide levels without, imagining that people are suddenly going to stop flying or otherwise materially change their lifestyle, because we're not.
Are there approaches to sort of directly impacting the climate that you think we should be investing more in? I mean, you mentioned the physical sunshade, which is really interesting. Are there other things that are kind of percolating out there that should be getting more attention, you think?
I'm thinking a lot more recently about localized cooling and fire prevention. Um, Things like marine cloud brightening. There's a lot of basic science that still needs to be done. Like, my understanding is that it's unclear whether marine cloud brightening net produces warming or cooling. And scientists think it's highly dependent on maintaining really tiny molecule size with your aerosolized salt water, which is really hard and maybe impossible. So, like, more basic science on that, particularly things like marine cloud brightening and other localized things, because people are going to start deploying those. They're tired of seeing their cities burn or cook. And whether it's net warming generative or cooling generative, those are going to be deployed. So we should learn as much as we can, as quickly as we can, to deploy those in a way where, obviously putting water droplets or something else over a city is going to cool things off. Ideally, we research enough to make sure that we do that in a way that's good rather than bad for the rest of the planet.
Could you describe in a little more detail what's actually happening with your process? So the actual kind of mechanism that's causing the cooling. I've read that you've mentioned the balloon itself is biodegradable, but also the material that you're putting in the atmosphere and the stratosphere is biodegradable. I'm curious sort of how long the effect lasts, what kind of effect it's having. You could just sort of flesh out the details in a bit more technical sense. That'd be awesome.
Yeah. So this idea sounds very crazy at first. Part of what legitimized it for me, and hopefully does for others, is learning about the effect that some of the more powerful volcanic eruptions that have reached higher altitudes can have. If a volcano's plume reaches the stratosphere, it's called a stratovolcano. Really famous one happened in the Philippines about 20 years ago, and it was called Mount Pinatubo. When that erupted, that was the first stratovolcanic eruption where we had really good satellite data monitoring the effects of it. This one volcanic eruption dropped global average temperatures for 2 years by about half a degree Celsius from one volcano erupting. And nothing particularly insane other than that reduction in temperature happened in the years following that. So we know, kind of as an upper bound, that you can have an eruption of that magnitude to create that amount of cooling and the world's not going to end. So, like, we're copying a natural process. There was also a really crazy natural experiment that happened with marine fuel. Many cargo ships burn the least processed fuel that they legally can. Often it's called bunker fuel. And it's like, very viscous, like minimally processed crude oil. And traditionally they would burn that and it would emit a large amount of sulfur dioxide from the sulfur content in the fuel. International Maritime Organization a couple of years ago changed their regulations to require either less sulfur in the bunker fuel or scrubbers on the smokestacks to remove some of the sulfur dioxide. Because of that change, as I'm supposed to put a disclaimer from climate scientists, like, when equalized effects are finally occurring, will be about 0.06 C warmer globally. And you can actually see a difference in the reflectivity of the plumes of where all these giant maritime routes, like LA to Shenzhen, for example, it's a different color in satellite photos of reflectivity. In case that's not crazy enough, if we were to just take the amount of sulfur that we removed from marine fuel a couple years ago, take that amount of sulfur and instead move it to the stratosphere, which is technically challenging, but certainly something we could do. If we did that, we actually don't know how much cooling we would generate. It would definitely be over 3/4 of a degree Celsius. It would likely be over a degree Celsius. Even more aggressive people like me would not do that right away. There's things like stratospheric heating at that magnitude that scientists tell us we might need to be concerned about. But I would do a small fraction of it and do much larger balloons than we're doing, roughly the quantity of flights that go through Atlanta International Airport per year. And then we drop global temperatures noticeably. We'd be like 0.2 to 0.5 C. And I'm of the normal for startups, crazy for some critics in academia, belief that as we do things, we will learn. And before we do them bigger, we'll learn about how to do them, which is just like, you know, kind of all we do in startup world. We build minimum viable products, learn from them, and then scale it up and, you know, rinse, lather, and repeat. But yeah, not so much in academia. Mainly, it appears to be, the more I learn about it, the more it appears to be fighting over bureaucratic processes around getting more or less published and more or less grant funding.
Somebody told me this concept once that our pollution is actually helping to cool the earth, and when we stop polluting, we'll have to we'll have an additional sort of warming effect that we'll have to overcome. It sounds like that's kind of related to what you're saying, but is it really just about sulfur dioxide that's having that effect?
It's particularly reflective. Any particle you put up is going to have some warming or cooling impact. Technically, sulfur dioxide is, I think, the most reflective of the things that we've changed recently. There's also a large amount of it in aviation fuel. For example, a 747 flight from San Francisco to New York emits far more sulfur dioxide than all of the balloons that we've launched so far. So it's this comical thing where, like, I get it, our approach is different, but any quantification of the risk from what we're doing and the quantity that we're deploying, and also the altitude at which we're deploying it, compared to the ship plumes, we're something like 22x more cooling per gram that we deploy. That's why we'd have such a strong temperature, because we have longer residence time by getting to the stratosphere, and chemistry that I don't fully understand. The sulfur dioxide reacts to produce other things and is not as dangerous to humans per unit deployed. So yeah, it's really just kind of comically absurd how upset some people get about this. And also, zooming way out and being, you know, more honest than maybe many in climate tech will be, like, yes, I'd like if there were magical international consensus meetings and everybody agrees to do this, but everyone, or even a majority of people, agree that we should do this is not a prerequisite to us doing it. Almost everyone would agree we should magically, you know, power things with unicorns and stop all fossil fuel extraction. They're still going to continue flying, and we're not actually going to do that. At the end of the day, like, what I care about is making this happen at scale, because there's such a clear reduction in the harms that are occurring from our, silly to even say it, we reduce the harms that are occurring from global warming if we introduce some cooling. Like, it's just, you know, it's tautological, like, it's obvious.
Is the effect local or global? Like, if you launch a bunch of these balloons in the US, do you cool the US preferentially?
Scientists tell us you need about 6 to 12 launch sites globally to ensure that you're not majorly, like, that there's no realistic chance of disruptions to weather patterns. And because we deploy as an aerosol, there's no, fortunately and unfortunately, fortunately because, you know, we get such extreme leverage, the math is roughly, with, you know, error bars like there are on CO2 and everything else when you talk about atmospheric science, the shortcut math is roughly that a gram of our clouds offset the warming of 1 ton of CO2 for 1 year. And unlike many other people, we match up the time frames, because anybody who doesn't is just a scam at the end of the day. Like, people will either be assuming like GWP 100 or 80 or whatever, but unless someone is explicitly telling you the time frame for which they're matching carbon, they're fraudulent. And most of these efforts are, to be clear, almost all of the reforestation efforts, like, don't trust me on it. Big paper from the Guardian, and this one in Nature a couple months ago as well. Over 90% of save the world by taking this airplane flight and paying an extra dollar. Not all, but over 90% is the estimate of those are just fully fraudulent, where there is no additional carbon removal occurring.
How did you arrive at balloons as the delivery mechanism? Was that an obvious choice from the beginning?
What I really wanted to do, and what most physicists will tell you makes the most sense, is make a giant hose to the stratosphere using most advanced materials we can. There's actually a paper from Innovation Endeavors, Nathan Myhrvold's thing, from like 15 years ago, where he maps this out, like roughly how to do it. I asked some early employees at Project Loon about this, And they explained to me that even being Google's balloon internet project and having a Fortune 500 client who wanted them to do it, even they could not do a tether from the ground up to even a kilometer, let alone to the stratosphere. So if a military wants to do this, if they want to do it in 10 years, the right way to do it is a tether. If they want to do it tomorrow, they can declare war on global warming and use existing military planes. Even some of the MiGs can barely get to the stratosphere. You used to be able to, they're canceled for now, but you used to be able to, in Florida, get a ride in a MiG that would take you to the stratosphere. I think the FAA pulled their permit. It's, not a particularly safe maneuver. Apparently the afterburner goes out like at the height of the flight sometimes and may or may not come back on the way down. We have the technology largely from war to do this. Anything that goes super fast also can get to the stratosphere. Any of the supersonic stuff has to fly high to reduce the air friction. So yeah, I don't know of an exception. Every supersonic thing that we've looked at would be capable of being used as a delivery vehicle. Balloons are the right way to do an MVP because they're cheap, they're scalable. Right now, the ones we use are biodegradable, and academics have fully written them off. Step one, if you ask two of the lead researchers on solar geoengineering, is to spend $20 billion in 10 years building a fleet of custom high capacity, high altitude aircraft. That's like their step one, which, that approach kind of helps explain one of the many reasons why people haven't just done this. And, it's comically the wrong approach if what you care about is getting started and learning.
But that somewhere on that, in that realm of solutions would be the future of make sunsets potentially as you get to bigger scale.
Ideally, the future of make sunsets is that humanity gets our shit together and we don't have to exist anymore, right? Fusion and fission, scaled solar, way better batteries, et cetera, et cetera. Governance of geoengineering broadly, as in our carbon-based negative geoengineering that we've been doing that got us into this mess in the first place. But yeah, realistically, we think I'm happy to do all of it if governments want to pay us. And, there are examples of that. There are technology companies where governments don't do it themselves, but many governments will buy, the same jet engines, even the same jets, the same software, some of the same hardware from a company. Apple and others are good examples of companies that sell to a variety of governments. There are things that technically a government probably could do, but doesn't. And very few are interfering with Apple's freedom to operate, even though they're selling, magical tools that let you communicate securely with anyone in the world. Like, yes, we're controversial, but if you step back and, take a decade or more back perspective, what any technology company sells is magical and controversial if it didn't incrementally exist along the way to here.
What is cool or hard or interesting about the challenges you've had to face so far from a hardware perspective?
It has been a very humbling experience to try to get my $200 foam RC airplane to return to me from the stratosphere. I've spent way more hours and way more planes on this than I'd like to admit. It seems like it'll be easy, and then you realize that you're going from temperatures of ambient or a bit higher if your plane's insulated as it ascends, down to like negative 50 C at the stratopause. Apparently, we hit levels of radiation in the stratosphere that are something like a tenth what spacecraft deal with. So even when I get this working, it's going to, you'll randomly have bits flip. Like, that's a real thing. Yeah, it's fun, and I'll get it working eventually. But it's been very humbling, and it'll be cool when it happens. I don't know how quickly they'll adopt it, but some researchers have told us there's a chicken or egg problem with flying instrumentation on their weather balloons and through volcanic plumes and other things, because you want to fly fancy, high accuracy sensors, but those are expensive and heavy. So you can fly them, but if you're going through a volcanic plume or anywhere to the stratosphere, you're going to lose them a lot of the time. So we hope that by basically just saving a couple $100 per flight for us and getting consistent video footage of our balloons bursting and not having to, trek through the wilderness to try to recover the cameras, by making our payloads come back to us, we think we'll have a general tool that others will be we'll be excited about using for photography, for data collection in the stratosphere, et cetera. Even for monitoring what people who don't like this can buy our flight vehicle when I get it working and try to use it to keep an eye on us.
Okay, sorry. So where does the airplane come in? Is it a part of the payload with the balloon, and then it comes back down? It flies back down.
That's exactly right. The traditional way that almost everyone does it. And Noah had a project that like half got this working years ago. A friend in the 20-year-old hacker in Switzerland has this working and is selling it to some other company. But almost all of the weather balloon flights that occur, they'll just have a parachute and a payload. And sometimes they'll have a transponder so that people can, there's like a small niche of radio enthusiasts who will go and hunt for these weather balloon transponders, then program them to do other stuff or return them to the weather service. But these payloads are cheap because they get lost a huge proportion of the time. And even the number of flights that occur is somewhat limited by budget, because if you're losing your payload every time, you can't put up as many weather balloons as you otherwise might.
Got it. So this gets into, this is my next question. You've talked about learning. I'm curious, what are you learning, and how are you learning those things from the launches that you're doing? What kind of data are you collecting, and what does it actually tell you about what's happening?
Yeah, one of the things that some researchers will criticize us for is that we're not like advancing the state of the art on understanding of particle physics in the stratosphere. And like if I could snap my fingers and do that, I would, but like that's not what our customers hire us for, and that's not what I told my investor I'd achieve. What we measure is what our customers told us they care about, which is how much sulfur dioxide we're deploying and at what altitude. And that's what we report back to them. When you buy a cooling credit from us, it's a concept we made up. 1 cooling credit equals 1 gram of sulfur dioxide deployed to the stratosphere, roughly offsetting the warming from 1 ton of CO2 for 1 year. When you order that from us, you get a thank you email, and then about a month and a half later, you'll get another email saying, congratulations, your cooling credit's been deployed. This balloon launched on this date, reached an altitude of, our average is something like 23,000 meters. It carried 1,500 grams of SO2, representing 1,500 cooling credits. Yours was number 1,401 or whatever. So each one, we tell our customer when it's deployed. Unlike, any of the tree planting things I backed, you'll just get like a feel good picture of a kid planting a tree and that's it. And it's, obviously. So we're different now, and we'll be extremely different when we get return to home working. And I can say, here's the balloon that carried your credits bursting. It looks really cool. We've gotten a couple of videos of it. And you see the curvature of the earth, the color of the atmosphere, reflectivity around it. And then you see this balloon burst above it. It's pretty satisfying to see.
I did see that. I did catch a video of that, and we'll have to put a link to it in the show notes because it is super cool. Who are your customers?
They're basically on average, and there's a lot of variation. They're people who believe in technology's ability to do good. Obviously, they're usually later in their career, either by age or like, some of our customers have made money from hardware startups or from crypto projects or other things. And they're, for some reason, either age or amount of exits, they're taking a minute to think about their impact on the world. Many of them have kids or even grandkids, and almost all of them in some way are a job where they have to quantify things, whether engineers or programmers or something else. They're not interested in just the feel-good picture. They're looking at the data. And most people who do that with climate get real depressed and become climate doomers, which is understandable and arguably the most rational response to the data. But some will start to look at more out there things like us and think about, okay, per dollar, like where can my $20 on climate actually at least conceivably make a difference and support something that, I could at least someday maybe see scaling to solve the problem. And when they do that, they don't find much there, unfortunately. I hope that won't be the case in a couple of years, and I hope we play a small role in encouraging. And if anyone listening has a project that they think per dollar can materially impact climate, I'm happy to give them some advice about how to be scrappy about it and get it started. But right now, there's not a lot there, unfortunately. And we're lucky enough to have, we're a little over 700 customers so far, about $98,000 of total cooling credit purchases, which, isn't where we need to be to have a substantial impact on global temperatures, is the negative way to look at it. The positive way is if you look at amount of cooling generated last year in that year, we're larger than almost, if not all, of the direct air capture projects in our impact last year. To be clear, direct air capture done well has permanence, so it's an unfair comparison. But that how much you spend on direct air capture personally versus cooling credits, for example, should boring finance side of that is it should matter how much you care about cooling now versus in the future. If you're in an emergency, you should care more about now than 100 years from now. And if you think technology will make direct air capture much more efficient in the next several decades, as I hope, or just energy generation much more efficient, then you should prioritize measures now more than measures later.
It makes it a little challenging to compare apples to apples with like carbon removal because of the temporal aspect of it. But you could look at, I guess, like the cost of a cooling credit versus the cost of a carbon removal credit. Is that one way to compare them? And can you share how much a cooling credit costs?
A cooling credit costs us something like 30 cents. No, we're less than that now. Under 30 cents per cooling credit deployed is our cost. So the minimum, we might sometimes, if somebody does a big purchase, we haven't done it yet, but we might discount down to 50 cents on a really, really large purchase. If it's a large enough purchase that I'm able to reduce my costs further in generating the hydrogen or the sulfur dioxide in bulk. But right now our average price is something like $1.15 per cooling credit. So like, I'm also of the old school opinion that just because we're trying to save the world doesn't mean we can just burn investor money forever. Like overall profitable yet because, R&D and our salaries, but per balloon launch, we're profitable. A balloon launch will be on average about $1,800 of revenue and cost us something like $400 or $500 lately.
My understanding is sort of an aspirational price for permanent carbon removal or durable carbon removal is on the order of $100 per ton.
Yeah, aspirational being the key word.
And today it's more like 500 to 1,000. Or
I think some people will sell it for less. Like somebody did a future deal with Google. You can sell things for whatever you want, as long as you can convince investors to continue subsidizing it long enough. I was stunned that we raised any money from this, and I'm stunned every time we raise some more, and I'm flattered every time somebody buys even $1 of cooling credits. So I know this is a bit early for the world. We plan on getting to profitability and then getting to more profitability and staying there, so that not because we particularly care about the money, but because profitable means we can continue doing this indefinitely. That's exciting. Then we'll push the world to catch up. But then right now it's world catch up within 2.5 to 3 years, or we run out of money. And someone else can do this, but until many others are doing this better than we are, I'm excited to continue doing this for our customers.
Even let's say carbon removal even does reach that $100, that very aspirational $100 price. What you're saying is you could do cooling credits for 100 years, since yours last, has that temporal effect. You could do a cooling credit for 100 years for the same price, but you're getting the impact like immediately.
To be clear, they're aspirational $100. Like, I don't think anyone's cost to deploy cost for a full ton of CO2 captured. I haven't heard anyone legitimately claim that they're spending less than $200 to $250 in their cost to do that.
Right. And that's not even cost to the customers.
Yeah. And we're using really tiny balloons. At some point, we switched to really big balloons. Like our balloon's payload is about 1,500 grams. NASA regularly launches polyethylene balloons with well over a ton of payload. And like my sulfur dioxide cost scales quite well. Like I can buy a ton tanker of it for basically like twice what I buy 100-kilo tanker of it for. And then at some point we generate our own hydrogen occasionally. At scale, we generate hydrogen, and then that becomes our costs we'll be under a cent at true scale, like at 1,000x scale, certainly at 10,000x scale, what we're at now. I'll be well under 1 cent per cooling credit delivered, probably under a tenth, and getting near 100th. the hard cost is on sulfur. It's about $200 per ton of sulfur, and sulfur is about twice the weight of oxygen. So 1 ton sulfur roughly, there's some losses, but roughly translates to 2 tons of SO2. So our hard cost is $100 per ton for the material, and then whatever. It's actually less because it's sulfur dioxide is a pollutant. There's a future where we could get paid by people to filter this out of their smokestacks and then use that to deliver our cooling credits. But yeah, there's many reasons why this business might fail. It is not going to fail from our unit economics. That is something I will assertively say.
I just looked it up while we were talking. I can go and buy a cooling credit right now, it looks like.
You
Or I
can.
can subscribe for 30 cooling credits per month.
Yeah, it's been really cool to see people, anybody buying at all. Like, we get an email every time, whether it's a recurring purchase or one-off, and it's way more. A one cooling credit purchase provides way more than $10 worth of motivation to me, especially when it's a new customer.
So it sounds like you have these sort of, really engaged individuals as your customers today. Does scaling this look like getting to a place where you have a voluntary market similar to what we have in the carbon removal space? Is that the kind of thing we're counting on?
I don't know. I'm amazed that individuals is what has taken off. We have a couple small companies and a couple funds as customers, but almost all of our customers are just individuals. And I thought of this initially and still think of this as three potential customers: governments, individuals, and companies. I thought individuals were the least likely. Like, I thought no individuals, maybe like some high net worth people to make a point would, but I didn't think any individuals would buy from us. I thought it would be like companies occasionally, like if anybody continues to care about sustainability on the corporate front, some people, like some edgier brands, to make a point and be like, hey, we're not going to do bullshit things. Here's something real, and it's a little controversial, but there's this climate change thing you might have heard of. We want to actually do something that impacts it rather than have a pretty picture of a fake tree. And then governments at some point. I think how this happens is that one of the developing nations, like G8 or G20 even, does this for domestic political capital, like somebody to win re-election somewhere is like, hey, it's not going to be tomorrow, but likelihood of monsoon, likelihood of, crop failure, blah, 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 all of these climate things everyone has noticed all the time is going to be reduced because we're deploying this thing. And by the way, we're going to charge the rest of the world. Like, India could deploy this and say, hey, farmers who are an important voting bloc, like, not tomorrow, but you can expect less climate volatility eventually as we stabilize climate. And by the way, rest of world, we're going to do this for the first several years, and then you're going to pay us to continue doing this because we're stabilizing climate globally. We're going to do it whether you like it or not, and you need to pay us if you want us to continue doing it. So I think the ROI is such, like, people will bemoan these kind of tragedy of the commons things where you're doing something and others benefit from the value. I think that's not soluble entirely with markets, but I think when you have something super effective like this that delivers such an important value, I don't need to bill everyone in the world for a stabilized climate. I just need to find some number of people willing to pay for it. And, that benefit to those people. This is so leveraged, and people are so understandably concerned about climate that this is something that, a billionaire could decide that instead of having a pissing contest to have the next phallic space object, they could instead stabilize world climate for a couple of years. Like, that could literally be their legacy. And it's funny because some of these people are, they're at least tweeting about how we really should do research on solar geoengineering. So you have billionaires who almost definitionally made their money by deploying in the face of ambiguity, calling for more careful research. And at some point, somebody pulls the trigger there and says, you know what, this is a little silly that we're just having people write reports on the potential 1% impact on maize yields in Ecuador, which is like one of the levels of reporting as people grasp for downsides to this that is actually getting funded. One of these people, hopefully, will say, you know what, I'm going to do this. And whether they do it with us or on their own, obviously happy to do it, but that it gets done is the important thing.
I appreciate you saying you hope that Make Sunsets isn't needed in the future. Like, we solve our other problems and we don't need to do this kind of solution. But I am curious, like, what scale of impact do you think this company could get to, or do you have aspirations for, and on what kind of time frame? In 5 years, if everything goes as planned, or 10 years, are we having like fractions of a degree of impact to global warming, or how do you look at that?
When someone writes the check for it, I will deploy within 12 months of someone writing the check for it. I will deploy up to half a degree Celsius of cooling. We need no change to technology from where we're at. We need no difference in the chemicals that we're deploying or the lift gases that we're using. We're ready to go up to half a degree Celsius. That for me, I mean, frankly, like 0.1 C is that's a willing to bet the company kind of moment where I think when we do that, the discussion changes like it often does with novel technology from, oh, what about blah, 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 theoretical concerns to, holy shit, we have this tool that we could have been deploying already. And now somebody did it. The world didn't explode. And this is how we can do it more. And I think to redirect Greta Thunberg's famous remarks at the UN, people will say, what were you thinking? They won't say it just about our carbon emissions being so high. They'll say it about us waiting so long to start to deploy tools for global cooling. Yeah, there's no material barrier. Everything we're doing is legal. We can scale it in the US, we can scale it over open oceans, and we can find host countries when there's demand. Like the barrier between now and a world half a degree Celsius cooler is solely purchases of our products.
Just lots of balloons, bigger balloons, but lots of balloons. And there's no sort of supply chain bottlenecks or anything like that. That's something that's achievable.
In case this isn't crazy enough, the big NASA balloons are the same. There's like one molecule different, but you can literally use the same. It's polyethylene. It's the clear sandwich bag plastic. They're much thinner to make them more lift per unit, more free lift per unit lift gas, but you literally can make balloons out of the same material that we make sandwich bags out of. So that's not supply constrained. There's also no real, like, if a country gets mad about this, we're not going to fail because of that. The open ocean is a large and fortunately, mainly unfortunately, largely deregulated place. Like, to actually ban this, you'd basically have to regulate all emissions of climate impact gases everywhere. And, if you can do that, then you don't need us anymore because you've brought global warming under control as a side effect. So regulation will not be a reason why we fail.
Okay, I have three last questions for you. First is, how optimistic or pessimistic are you about the future of the planet, and why?
Very optimistic on a long enough time scale, because although we live day to day, when you zoom out and look at pretty much any measure of human progress on a decades, certainly on a century time scale, everything has gotten better all the time. Even like, dark ages will be a slight downturn in that a little bit, but the trend is positively, it's more up and to the right than any startup could hope for in their own metrics. So yeah, we'll continue to cobble along and make most of the mistakes most of the time, but innovate our way through our problems as we always have.
Who's one other person or company doing something to address climate change that's inspiring you right now?
You already had Casey on. That would be my first answer. I think that if people look more closely at not all, but most of the climate activism that's occurring, I think that they will respect it more the more closely they look. I'm fairly certain Just Stop Oil has not damaged any of the paintings that they have carefully thrown soup onto the protective covers of. Stonehenge is the closest to an exception. I think they had like several plant biologists or like archaeologists confirm that they could do that without any serious damage. Like, these are thoughtful people. You may disagree with them on some of the details, but that happens to be activism I agree with. If somebody's willing to do activism in general, they're probably worth a minute to pay attention to. I think looking at what people are doing that is extreme for non directly monetary reasons is probably something we should all pay attention to.
What advice do you have for someone who's not working in climate today but wants to do something to help?
If I was worried about like profitability as a small business, I'd do a greener version of almost any service business. We are, at least theoretically, about to deport a lot of skilled laborers on the trade front in the US, and a good chunk of our country is burning or flooding or otherwise climate damaged and needing torn down and then rebuilt. Having worked in software jobs and in hardware jobs and in the trades a little bit, the headlines aren't fake. A welder on average with, an associate's degree or just a certificate makes more than someone with a bachelor's in English literature from a fancy university. You can switch back and forth between these, right? Like, because you did software, you did blah, 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 doesn't mean you always have to. And not everything has to be a high growth startup. I think there are tons of opportunities that can be a great blend of environmental impact, lifestyle. People derisively call things lifestyle businesses, but like many of the happiest business owners I know have like machine shops or construction companies that's, sometimes just them or them and a couple friends, but those are real and important businesses. And, if you do those for a while, you might accidentally stumble on some element of it that other people who do that want, that can make their jobs way more efficient or environmentally sustainable. And when it's end of long rant, but when it's something where, like construction, where if you do something in a more efficient way from a materials or energy perspective, you're saving yourself money and more environmentally sustainable. So that nice overlap can, that can be a hotbed for coming up with things that, one, make your business work better, and two, could actually scale to be a high growth startup.
Luke, this has been really fun. I've learned a lot, and I really appreciate what you're doing. Thank you.
Thanks for having me. It's good seeing you.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.